Hello YouTube, it is QNix. I'm back with another tutorial for you. This is a good day for QNix viewers who love to learn how to apply my effects. I'm bringing you 2 tutorials within the span of a week. And the tutorial that I'm going to be sharing with you today is on YCoCg color splitting. So YCoCg color splitting, before I get into how to apply the effect, I just want to briefly overview what YCoCg is. YCoCg is a color space that follows a similar idea to things like YUV, YCBCR, YPBPR, where instead of expressing the colors in a video as just a simple sum of red, green, and blue components, we are transforming it so that we have a single channel represent the lightness of the color, and 2 other channels represent the color itself. So the difference between YUV, YCBCR, whatever, and YCoCg is that the coefficients in the transformation matrix to get from RGB to YCoCg are much simpler. In YUV and YCBCR, YPBPR, what have you, the coefficients have a lot of decimal places, and the reason why there are so many things like YUV, YCBCR, YPBPR is because, to the best of my knowledge, it doesn't seem like there's been real agreement on what is best. So YCoCg takes a different approach. Instead of trying to refine the coefficients as much as possible, just make them as simple as possible. So here, the Y component is simply a sum of half the green channel and a quarter of the red and the blue channels. The CO channel is just half red minus half blue, and CG is just half of green minus a quarter of red minus a quarter of blue. And we can see that even though the coefficients are pretty simple, the channels do convey pretty well the colors that we see in the picture. On the right, there is an example of a barn in a field with some mountains. The barn is like a brown, the ground is green, the mountains are gray and blue. Now, if we look at the first picture underneath the color one, this is the Y channel, and this is meant to convey the grayscale information of the lightness of the picture. And it does a pretty good job. We see, this pretty much looks like a black and white version of this picture up here. Maybe the only difference is that in the color picture, the barn appears a little bit brighter than it does here, because the red coefficient in YUV is normally larger. But otherwise, the lightness of things up here pretty much correlate with the lightness of things down here. We move on to the next picture, which is CG. The grass is green, it shows up green. The mountains are kind of this cool gray, so they mostly show up like a dull pink, and that's because the blue channel contributes to subtracting from CG. And then we move on to the final picture. This is CO, and the barn is brown. This is like a dark orange, so of course it shows up orange. The sky is blue, it shows up blue. The mountains are kind of a grayish blue, they show up blue as well. So the idea of YUV is preserved. We have 2 axes for representing color and 1 for representing lightness, but the transformation is much simpler. And I think that it's just a better transformation overall because RGB is so common, and YUV is kind of an ancient trick in order to help reduce the bandwidth of data that was transmitted over signals and cables and such. But we're kind of in an age that we don't need that anymore. There's other reasons why I think YCoCg and RGB are better, but I want to talk about that separately at some point. I've had enough fun educating you guys. I'm going to be talking about how to actually apply the effect where we split up the video or picture. You can apply this to a still image as well. We're going to be splitting up the picture or video into YCoCg components. Now, just because the transformation is simple does not mean that implementing it with non-professional tools is simple. This is one of my more complicated effects, and not only did I end up using a pretty complicated FFmpeg command line when I was putting this together, but I actually had to do matrix multiplication in Python in order to get some transformation matrices that I needed. So I'm going to be guiding you through the whole thing. I've got two command line windows. This one is the one where my video is. This is where I'll be making my FFmpeg command line. The other one is going to be where I do the matrix multiplication. Now, before I apply the video, before I apply the video effect, I will just say that in general, it is best to apply this effect to some video with a relatively diverse range of colors. Because we are going to be extracting the color information and presenting it in sort of a pure form, we want to make sure that we actually have some color information to pass on to the effect, because if the video is mainly black and white or mainly has a single color of various shades, then the only channel that's going to actually have any information in it is the Y channel. So I'm just going to play for you the example that I chose for today. It's the Charter Entertainment logo. It's got those stripes going on behind it that gradually turn from green to blue to pink. They have various likenesses, so I figured that would be a decent example to start with. Now, I will also do something a tad different with my FFmpeg command line. So let me start an editor. So I'm going to make a shell script for the sake of this tutorial that's going to have my FFmpeg command line. Now, I will be typing this in a way that's not going to work. FFmpeg likes to have all of the effects on a single line. However, that will completely ruin the presentation. It's going to make it really hard to discuss the individual steps. So I'm going to write it in a way that's a bit more presentable. Then I'm going to apply some edits afterward in order to make it usable. So before we apply the effect, we're going to do all the usual stuff. I'll also link my corner logo in after this is all done. So I think this is all we need to get started. So we're going to have FFmpeg. We don't necessarily need a corner logo. I know sometimes people ask about not applying one. At the bare minimum, all we need to specify is the input video that we're using. We're going to start lavfi because we're going to be applying a pretty complicated string of effects. And lavfi means we can deal with multiple different inputs and outputs. So I'll start by simply saying, let me put this on the next line just for the sake of readability. So 0 is my input, and I'm doing all the typical stuff that I do to scale up the video. Take off some of the edges. Oops, I'm getting a little bit ahead of myself. I'll put this on the next line. MI mode equals MCI, MC mode equals AOBMC, ME mode equals BIDIR, VSBMC equals 1. So at this point, I haven't done anything different from what I usually do. These are just the steps that I do to upscale a video that's coming from lower quality source media. So I crop out the very edges by just specifying that the width and the height should be 95% of the input width and height. I scale it up to 720p, then I apply and interpolate so that it gets to 60 frames a second. This is where things are going to start getting different, however. At this point, I usually scale up to 3840 by 2160 because I render my videos in 4K. I'm going to scale this up to 1920 by 1080. H equals. And the reason why I'm only scaling it up this far is because in the final video, we're basically going to have a 2x2 grid of the video with 4 different types of colors. We're going to have the Y channel, the CO channel, the CG channel, and we're going to have the original. So we don't need to render the video at full resolution. We need to render the video at half of the true output width that we want and half the true output height. So if you were rendering a video in 8K, then yeah, this would be 3840 by 2160. If you're rendering a video at 1080p, this could be as small as 960 by 540. I'm going to apply denoising, as I typically do. Not strictly necessary, I just think this makes things look better. We're going to do another new step. I will convert the format to RGBA. We are going to be working with RGB channels, so we need to make sure that the input format is RGB. Typically, FFmpeg will take care of that conversion for us, but there's a reason why I'm explicitly doing this conversion here. The transformation matrices that I make are going to involve operating on the alpha channel, which in this case has to be 1. What I'm trying to do is, in the Sony Vegas channel blend effect, you could add a coefficient for what's called the bias, which is basically a constant value that was added regardless of what the input values for the other things were. Now, FFmpeg has no such thing, but because we don't expect that we're going to be working with transparency, what I'm going to do is I'm going to set the alpha channel to 1, and that is going to be the channel that I use to supply the bias. Now, if I didn't do this conversion, then FFmpeg would not assume that the alpha channel is 1. It would say that there is no alpha channel. And the effects could be unpredictable, but usually what happens is it treats the alpha channel as 0, and that's a big problem. So we need to set the format to RGBA. Then I'm going to make another effect, color levels equals AO min equals 1.0. So now we've got the right format, and we forced the alpha channel to be 1. So the video is not going to have any transparency, and we're going to be making sure that we provide the right information to Color Channel Mixer when we apply the effect for real. Then I'm going to split up our video at this point, because we need to operate on this 4 different times. I'm going to make 4 different streams. I'll call one Y, one CO, one CG, and one OG. So after applying the upscaling, changing the format, and setting the alpha channel to 1, we are now going to be working with 4 different copies of the video. One of them will be called Y. This is where we apply the Y channel. One will be called CO, because we're going to be applying the CO channel. One will be CG, because that's where we're applying the CG. And one will be OG, because this is going to be the original. We're not going to touch it. Now, let's get started operating on Y. So Y is the lightness channel. And let's go back to our web page on the transformation matrix. Transformation matrix. Now, the notation for matrix multiplication is a little bit strange. So, to show you what's going on here, what this is saying is that the Y channel equals 1/4 times red plus 1/2 times green plus 1/4 times blue. Now, the problem is that our output video is going to have 3 channels. It's going to be RGB. Even though we're showing off the Y channel, ultimately the information that's going to be coming out of our displays is RGB. So how are we going to handle this? Well, we look at the Y channel example here, and we see that this is just a grayscale image. And if it's a grayscale image, what this means is that R, G, and B have all of the same values. In black parts of the picture, R is 0, G is 0, B is 0. In white parts of the picture, R is 1, G is 1, B is 1. So I'm going to set up a matrix that sets all of R, G, and B to equal the transformation for the Y channel. Now, how does the color channel mixer effect work? I'm going to be following this with a lot of numbers. So I'm going to write this out sort of like this would be done in Sony Vegas. Now, everything that I start writing beyond this point isn't actually going to be in the script. This is just me showing you how the color channel mixer works. We're going to have a series of 16 numbers. So let's say my red output equals A times red input plus B times green input plus C times blue input plus D times alpha input. And the same thing will happen. Green output will be F times, I guess I could do E. You guys can pick up the context. E times red input plus F times green input plus G times blue input plus H times alpha input. Blue output is going to be I times red input plus J times green input plus K times blue input plus L times alpha input. And finally, alpha output will be M times red input plus N times green input plus O times blue input plus P times alpha input. So I just wrote a series of 4 equations which transform the output red, green, blue, and alpha channels based on the original values of all 4 of these channels. This is very similar to how this works in Sony Vegas, with the only difference being that in Sony Vegas we have these additional terms at the end that are just, they're not multiplied by anything. We're not going to be working with those in FFmpeg because they don't exist. Now, in order to actually implement the transformation matrix, you're going to write color channel mixer equals A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P. So A, B, C, D, etc., all the way up to P, these are the coefficients that you're going to want to apply. And these are not going to be letters. They're going to be numbers, and you're going to have to decide what they're going to be. But when you do decide what they're going to be, you're just going to write the 16 of them in order. So just to give you an example, for the color channel mixer, or I'll say below this line, not in the script. So let's say I want to make a grayscale output video, which essentially applies the transformation from RGB to Y. Well, first I would say that my red output is going to be 0.25 times red, 0.5 times green, 0.25 times blue, and 0 times alpha. So I've just said red output is 0.25 times red input plus 0.5 times green input plus 0.25 times blue input. And because the green and the blue channel are going to be the same, I'll just say 0.25, 0.5, 0.25, 0, 0.25, 0.5, 0.25, 0. So red, green, and blue are all taken care of. The only thing that we are missing is alpha. I'm going to put this on a new line so it doesn't go off the display. Now, alpha is different because alpha is the transparency channel, and because we're working with just the colors, we're not concerned about the transparency at all. We just want there to be no transparency whatsoever, which corresponds to a full alpha of 1. So I'm going to say for alpha 0, 0, 0, 1. In effect, red equals 0.25 times red plus 0.5 times green plus 0.25 times blue. Green equals 0.25 times red plus 0.5 times green plus 0.25 times blue. Blue equals 0.25 times red plus 0.5 times green plus 0.25 times blue. And alpha equals 1 times alpha. All right. And we're done applying the transformation matrix to the Y channel. So I'm going to make a new channel, YT, which stands for Y transformed. Now, for CO, we're going to break out the transformation matrix. And we're going to end up using Python to help us out. So let's bring this over here. And do some matrix multiplication. We're going to need NumPy. Now, I should specify that if you want to do the matrix multiplication yourself to see how I came about deciding on the coefficients that I did, you're going to need Python with NumPy. If you just want to apply the same coefficients that I show you in this video, you are not going to need Python and NumPy. You don't need to do this matrix multiplication yourself, but I do want to show you how I got to the values that I did. So because I'm working on CO, I want to apply the coefficients. CO equals half times red minus a half times blue. So let me make a matrix here. I'll say CO equals an array. Now at first I'm going to treat this like I am working with the Y channel, where I set R, G, and B were just equal to the same thing. So if that's the case, then my output is going to be 0.5 times red, 0 times green, and negative 0.5 times blue. And now I would like to also talk about where the bias comes in. we encounter an issue where the Y channel is a scale of 0 to 1. It's a quarter times red plus a quarter times green, or a half times green plus a quarter times blue. If all of R, G, and B are completely off, there's no color, then Y just equals 0. If R, G, and B are fully on, then this equals 1. A quarter plus a half plus a quarter. Cool. CO and CG are different. These are on scales of a half to negative a half. And this is not good because when FFmpeg works with color levels, it doesn't like to go below 0 or above 1. It likes scales to be from 0 to 1. So I'm going to add another term called the bias, which is going to shift the sort of default value of CO so that it is 0.5. Now, what would CO look like now? If I simply have no red or blue information, CO will be 0.5 times 0 plus 0 minus 0.5 times 0 plus 0.5. It would be a half. If I had full red channel and no blue, then it would be 0.5 times 1 plus 0.5, which is 1. And if I had full blue information, it would be negative 0.5 times 1 plus 0.5, which is 0. So now we have the channel going from 0 to 1 instead of negative a half to a half. This is good. I'll do the same thing for the others. Negative 0.5, 0.5, 0.5, 0, negative 0.5, 0.5. So this would correspond to red, green, and blue. Alpha, of course, is different. This is just the transparency, and we just want no transparency whatsoever. So full alpha channel, 0, 0, 0, 1. So if I applied this matrix to the video using Color Channel Mixer, I would get a grayscale image that has the CO information. But I don't want a grayscale image. I want the CO channel to look orange when it's high and blue when it's low. So I'm going to make another matrix. CO2C just means CO to color. And let's think about how this would work. Well, the particular shades of orange, blue in this picture, what's going on here is that the maximum value of CO corresponds to red being all the way on, and the maximum or the minimum value of CO corresponds to blue being all the way on. But because there's no green information, we just set the green channel to a half. So what I'm going to do, I'll first construct the matrix and then I'll explain why. Yeah. Okay, so this is the matrix that I'm going to use to transform my grayscale image into an image with orange when CO is high, blue when CO is low. Now, why did I decide on these particular coefficients? Well, first of all, I'll start with green. Here's red, here's green, here's blue, here's alpha. In CO, the colors of the output always have green just be a half. So I'm saying green is 0 times red plus 0 times green plus 0 times blue plus a half. Green should always equal a half. Now, for red, I want the image to be orange when the value of CO is high. And in order to do that, I just want to keep red to be correlated with CO. So I just say that red is going to equal the value of CO. On the other hand, I want blue to be the negative of that. I want blue to be higher when CO is lower. So I'm going to set its coefficient to -1, but I will also set the bias term to 1. So with red is 0 when there's no CO and 1 when there's a lot of CO. With blue, it's 1 when there's no CO, and 1 minus 1 when there's a lot of CO, that just equals 0. And alpha, I'm not applying any transformation to. That's going to be 0, 0, 0, 1 like I've always done. Finally, in order to get the actual coefficients that I want to apply, I'm going to multiply the two matrices. And let's just check that these coefficients are sensible. Would I get a video that is orange when CO is high, blue when CO is low, if I applied these coefficients? Well, with red, I'm saying that the red channel is going to go up when there's red, it's going to go down when there's blue, and if there's no information, it's going to be at half. So this makes sense. With the green channel, that's just always going to be half. That makes sense. Blue varies in exactly the opposite way as red, which is good. It's going to go down when there's red, it's going to go up when there's blue, and by default, it's a half. And the alpha channel is just what we want. I know this was very abstract. If you understand matrix multiplication, I hope this was useful to you. If not, I just want to show you that this is the thought process that I did in designing the coefficients that I'm going to apply in this effect. Basically, I was saying, first I'm going to make the image convey the CO information but be grayscale. Then I'm going to convert that grayscale image into an orange and blue image. So now that we have these coefficients, let's go back to our script. And let's look at the first row of the matrix. It's 0.5, 0, negative 0.5, 0.5. 0.5, 0, negative 0.5, 0.5. Let's look at the next row. 0, 0, 0, 0.5. Let's look at the third row. Negative 0.5, 0, 0.5, 0.5. And then let's look at the last row. 0, 0, 0, 1. And this will go to COT, CO transformed. And I'm going to do a similar thing with the CG channel. So I'll set that up, and I'll go back to Python and back to the transformations matrix. So the CG channel, the coefficients to get from RGB to CG are negative a quarter, a half, negative a quarter. So let's define a new matrix. Negative a quarter, a half, negative a quarter, and then we're going to have no dependence on alpha. Negative a quarter, a half, negative a quarter, 0, negative a quarter, a half, negative a quarter, whoops, there we go, 0, and of course the alpha channel is just going to be 0, 0, 0, 1. This looks correct. Now, when we are displaying this, we don't want it to be grayscale. If I applied this transformation matrix to the video, it would convey CG information, but it would be in grayscale, with white corresponding to green and black corresponding to anything that's not green. So I'm going to transform this again so that white becomes green and black becomes magenta. And how would I do this? CG to C. This one's a tad more complicated because I'm actually working with 3 colors. Previously, basically all I had to worry about was red and blue. And would it be more complicated? Actually, I think it would be okay. I think I could do the same thing. Let me give it a try. Yeah, I think I'll do it that way. Pardon me for thinking out loud. So if I want white to become green and black to become magenta, I should invert the red channel, invert the blue channel, and preserve the green channel. Okay. 1, 0, 0, whoops, -1, 0, 0, 1, 0, 1, 0, 0, 0, 0, -1, 1, and then 0, 0, 0, 1. So what have I done here? I said I want to preserve the green channel and invert the red and blue channels. So I'm saying that the red channel is going to be -1 times red plus 1. When there's no red, there's a lot. When there's no red in the input, there's full red in the output. This is what this 1 means. When there's full red in the input, there's 0 red in the output because we get 1 minus 1. We're just keeping the green channel as is, so this is why we have a 1 here. Green output equals 1 times green input. For the blue channel, we do the same thing as the red, so we have blue equals minus blue plus 1, and then the alpha channel is going to be the same as it always is. It's this 1. So then I'll multiply the 2 together, and I get a list of coefficients that I can use for this transformation. So this will output CG information, but high CG will appear green and low CG will appear magenta. Now I can go back to my script. So what do I got? 0.25, -0.5, 0.25, and 1. Let me just make sure this makes sense. Let's see. Oh, that's... Oh, I caught myself making a mistake. So if you'll notice, we have a problem here. In this final matrix, if I were to feed in some input video that had, for example, a magenta pixel, then the red channel would be fully on, the blue channel would be fully on, and the green channel would be fully off. And if I applied these coefficients, then we would have 0.25 plus 0.25 plus 1 equals 1.5. But we can't have the value of these colors go anywhere greater than 1 or less than 0, and the rules get broken here. And here's why. Remember when I made this matrix? I put 0.5 at the end of everything so that the default value of the channel was 0.5 instead of 0. Well, I didn't do that here. In this matrix, the default value is 0, and it can go as low as 0.5, as low as -0.5, and as high as 0.5, and that's not what we want. So let me redefine CG. Let's fix this. Let's put a 0.5 here. Let's put a 0.5 here. Let's put a 0.5 here. Let's look at CG. That looks better. And then let's do CG2C times CG. So let's see if this makes more sense. Okay, 0.25 red minus 0.5 green plus 0.25 blue plus 0.5. So if I have no color information whatsoever, it's just 0.5. If I have full red and full blue, then it goes up to 1. If I have full green and none of this, it goes down to 0. And anything in between will just fall in between that. Okay, fix the mistake. I think I'll actually leave that portion in the video because I want to show you guys what it's like to wrestle with this effect and show you the kind of pitfalls that I encounter. So let's go back to entering the coefficients. The first three were correct. They were 0.25 minus 0.5, 0.25, but the next one's going to be 0.5. Then we got negative 0.25, 0.5, negative 0.25, 0.5, 0.25, negative 0.5, 0.25, it's going a little bit off screen, 0.5, so I'll do a new line, and then 0, 0, 0, 1. This will be CGT, CG transformed. At this point, we have done all of the color transformations, and it was a very difficult journey with some trials and tribulations, but we got there. At the end of the day, we're just applying color channel mixer, a heck of a lot, in order to break down the color information here. So we have our 4 channels that we're going to end up joining together. We have the Y channel, which we transformed to YT. We have CO, which we transformed to COT. We have CG, which we transformed to CGT. And we had OG, which is the original, that we didn't really do anything with, which we don't want to, because we want to show the original video as an inset. So let me do this. I'll do YT and COT H-stack top, CGT and OG, we are going to H-stack bot, and then top, bot, V-stack all. So what I did here is basically 3 steps to building a 2x2 grid of videos. I said, well, the top row is just going to be the Y channel next to the CO channel. The bottom row is just going to be the CG channel next to the original. And the overall video is just going to be the top row on top of the bottom row. There is an effect called, I believe, X-grid or grid X-stack or something like that, which lets you arrange multiple input sources in a custom way in a single line, but I personally haven't gotten that to work properly on my end, so I just prefer to use multiple applications of H-stack and V-stack. If you figure out how to use X-stack and it works better for you, then that's awesome. And then finally, I will take my logo, which is input 1. I'll scale it to 3840 by 2160, LG, and then all LG overlay final. And then we're going to map my video. Whoops. I'll also do the audio upscaling because it makes my life a little bit easier. So I'll do 0A. I'll change up here to 0V. And I'll just do 0A. A resample equals 48,000. A exciter, A FFTDN. And this is going to be odd. Map odd to output. So I'll get rid of this stuff because we don't need it anymore. And I said I was going to write the script in a way that was better for presentation. Now, having multiple lines like this, FFmpeg is going to be mad. It wants everything to be on one line. So now I'm going to go through and erase all of those new lines. So everything is one big line. Can I shortcut this? Let me try shortcutting it. Almost worked. So this is everything I just typed before, but on one line. Oh, and we got another one. So now this should really be everything that I typed, but on one line. This is a very long command line, and I think you can see why I didn't type it this way when I started. So I'm just checking to make sure that everything is nice and neat on a single line. And we're almost at the end. Okay, so I'm going to save this. Let's see what happens. I called this render.sh. Let's see what happens. It didn't seem to like something that I did. Let's find out what the issue is. It said there was trailing garbage. Oh, A resamples, maybe that's a problem? I'm just going to quickly check to make sure I didn't miss anything else. You know, I'll just try rendering it again and see if that was the problem. Let's see. It says trailing garbage after a filter. I wonder if it said doesn't like VStack. Oh, whoopsie. I needed a semicolon. Alright, come on, don't fail me now. Oh, we still have a problem. Now it doesn't like LG. I wonder if this is because of the thing that I did. Let's change that to an H, scale W equals 30/40, H equals 2160, and let's try that. Okay, we're almost done. We're getting through this. And then I think the only thing I need is a space there. I don't know why there wasn't a space there. So I just had to correct some spelling mistakes. Let's see if this works. No such filter 0.5. I'm so sorry for taking you guys through all these mistakes, but I figured out why I was complaining so much. I did the same thing that I always do. I put commas where there are supposed to be colons. I don't know why. I use FFmpeg for so much. I don't know why I can't wrap my head around not using commas where there's supposed to be colons. So let's start replacing some of those. So basically everything in Color Channel Mixer that I put as a comma should be a colon. And that's a lot of commas. Okay. That should hopefully be all the mistakes. Now, before I make people nervous, I basically told you how to write this script, and then I told you, wait a minute, I screwed it up. I gotta go back and fix it. In order to prevent me from misdirecting you by mistake, I am going to be sharing the script that I wrote in its final workable form so that you guys don't have to sift through all the mistakes that I made. Although I do think it's worth you guys seeing the process of me building the script. Ultimately, I am going to make it a little bit easier for you guys to do this. Let's hope. Okay, this is a different error. I said the input file was original.mp4 when it's original.mkv. Oh, thank goodness, we're finally getting somewhere. Now, this will take a minute, because it's got to do a lot of thinking about splitting up the video. It's going to apply all these crazy coefficients. It's pretty typical when I use FFmpeg that it starts out not rendering for a while. It just says frame equals 0, and then it eventually picks up. You can see that it is picking up. And it shouldn't take long to render because the video that I've played is only a few seconds. So I'll let it go through the end. Okay, let's play this bad boy and see how it works out. It may play a little bit slowly because it's in full 4K, so if it doesn't look good, I will shrink it down and play it again. It's on the wrong display! Come on, over here. Let's try that again. Will it play on the right display? Stop playing over there! God! Alright, well, it looks good. It looks good. It looks like what I want. What if I did Dragon Player? Would it show up in the right place? There we go. And let's pause here. Let's pause. Let's pause. Okay, so let's take a look at the original and compare the output of our effects to what we see here. Let's look at these stripes. So we see a few things. There's a few stripes in the Y channel that appear brighter, and if we look in the original video, these stripes are indeed brighter. So this is good. We have these two stripes near the middle here that are mostly bluish, and the ones on the bottom are mostly orangey, and that does match what we see in the original video too. These two stripes are mostly blue. This one is straight blue. This one's kind of a greenish blue. Now, the two at the bottom aren't orange. They are magenta, but this is good for our effect regardless, because remember, in the CO channel, we're stripping away information about green versus magenta color difference. We're just looking at orange versus blue, and basically what we see with these stripes is that there's not a lot of blue. So we're good. And then finally, we notice in the CG channel, all the stripes on the top are mostly green, all the ones at the bottom mostly aren't green, and that indeed corresponds to what we see. So this was a successful, after many trials and tribulations, application of YCoCg. Now, if I wanted to apply this effect with no corner logo, this is something a question I get fairly frequently. Let's go back to, and I'll use Emacs, so this is all visible on the screen. So let me make a few modifications. I'll get rid of my corner logo input. We see that there is this line here that deals with resizing the logo. We don't need that. And we see that there is this filter that deals with overlaying the logo onto the video. We don't need that. That's going to go away. And then we're just going to map the end of our transformation, which is all. I'll test it just to make sure it's working. Okay, let's see if this worked. The joy of having multiple displays. Okay, it worked. Finally, I want to take this opportunity to show you what I think would be a working set of coefficients to apply with the channel blend effect in Sony Vegas. Now, I do not currently have Sony Vegas on this computer, so I can't test this to make sure that this is correct, but it is pretty much the same as what I've used in FFmpeg, so they are correct to the best of my knowledge. Please feel free to try them out, and this should work in any version of Sony Vegas that has channel blend effect with RGBA color space available. So there you have it, YCoCg. You split the video up into 4 parts, you apply a bunch of transformation matrices, you color channel mixer coefficients, and you put them back together. And I hope to explore this effect more. Thank you for sticking by me for applying this extremely complicated effect. I apologize that when I was putting it together, I made some mistakes and stumbled a little bit, but I do think it's worth it for you guys to see the process of me going through all of that in order to make the effect happen, because I think it sort of makes you guys appreciate the sort of intellectual effort that goes into these. And I hope it also teaches you that when you're putting your own effects together, you don't have to get them right or the way that you want them the first time around. You can keep working at them and try new things. And after some persistence and some willingness to correct your mistakes, you will find that your effects are going to look great. Feel free to ask any questions. Thank you for your attention, and have a good day.